Chapter 3. Okay, this chapter is control structures and data files. It's going to get much more interesting now. So the objectives for this chapter are, as stated here, we are going to, there we go, learn to use control structures, and that's going to give our programs alternative paths or choices within the program. We'll learn about repetition structures. So from this point forward, you should have no repeated code anymore in your programs. And then we're going to learn to read and write from data files, to and from data files, and a little bit more about linear modeling techniques. So next slide. Ooh, something happened to my slides. They were here a moment ago. Okay, so the book talks initially about this writing programming process. There's a method called top-down design, but that's basically looking at overall what your program has to do. That's sort of a definition of the problem statement, saying I need certain inputs, I need certain outputs, I want it to look a certain way. So it's a high-level, top-level look at the program. But oftentimes the program is very complicated, so what you end up doing is dividing the program into smaller sections. So this is a divide and conquer method. Kind of programming that we're working on right now is called structured programming. This means that our program has certain structures in it. We have control structures in our program. And our program is also all of our programs are using sequential structures. So one structure will get executed, then the next structure will get executed, and everything as the program progresses is executed sequentially. This is different from object-oriented programming. So I teach a class next semester in object-oriented programming. I don't know if that's going to be C++ or C# right now, but that programming in object-oriented is not necessarily sequential. So all of our programming here is sequential. One of the first, after you define the problem statement, so that's kind of your top level look at the program, oftentimes we write code which is called pseudocode it's not really that you're writing the code of the program, but you can do pseudocode even just verbally. Get values, store in location, compute answer, output answer. That technically is pseudocode. A little bit more formalized version of pseudocode is to make a flowchart. So flowcharts are actually very nice tools that tell you what's going on in a program. This is the flowchart example out of your book. Let me change here what I'm doing. So the flowchart notations, this is standard notations. Things like these trapezoidal shapes right here, they represent input and output in your program. So for example, read radius, print radius. I don't know if you can read it, but it's in your textbook also on page 83, in case you can't read the PowerPoint. So these are input and output blocks, flowchart symbols. When you see a rectangle like this, this is a computation or something that happens. It can be a computation like mathematically. It could also be writing things to a file, something that happens. This is a comparison. The diamond is a comparison. So there's going to be a test involved. In this case, it says, is radius less than 0? If the answer is yes, you go somewhere else in the program. If the answer is no, then you do something else in the program. So these are structures that give the program a choice. And this ovalish shape is always the start of the program and the stop of the program. They have start main, stop main. So it's nice to pseudocode out what your program needs to do and do it in a flowchart. They're actually very useful as the programs get larger. Oh boy, everything changed in this since I wrote it. So here's a flowchart example. it's a open rotor problem solution. And they just don't tell you what that is in the textbook, but I'm going to tell you this is an open rotor engine, a picture of one, open picture of the one. And this program would compute the velocity and acceleration of an aircraft that has an open rotor engine, which is an engine that looks like that. So using my flowchart symbols, I have a start main, read the time. It looks like velocity and acceleration are computed purely as a function of time. Here's a calculation block, calculate the velocity, calculate the acceleration, print the velocity, I do something. This trapezoid, I do something. I print, I read, print velocity and the acceleration, and then oval again, end the program. These steps that are taken by this program is completely sequential. You do this, you do this, you do this, you do this, you do everything in sequence. So we had a selection structure, which is a diamond shape, for our programs. Selection structures must contain some kind of a condition to be tested, with true and false being the outcome. It's always true or false. Even if you're doing a numerical test, you're doing a logical test, the condition will evaluate to be either a true or a false. So here I come into this part of the program, and it says, is absolute value of the denominator less than 0.0001? If that evaluates to true, denominator is less than that value, I get a true, which is a yes, and I print out something over here. If denominator is not smaller than that little number, no, it's a false statement. This would be a false statement then, and we go and do something else in the program. So this is a selection structure. It's actually also called a conditional statement or a control structure. Those are three different names for it. Conditional statement, control structure, selection structure. So we can have also, let's say I had to print a number many times. I would not want to write that print statement 20 times over if I had to print a number 20 times. So we can make loop structures. Loops allow you to not have repetition in your code. You write the code once, you loop back, and you keep doing that part of the loop over and over again. It must also have a condition statement associated with it. You must know when to get out of the loop. Otherwise you will have this thing called an infinite loop occur. So here's an example. I've set time equal to 0, and then I ask, is time less than or equal to 10? If the answer is no, it's not less than or equal to 10, then I will go and do something else. If it's not less than or equal to 10, say that again. I've set time to equal to 0. So I come here and I say, is time less than or equal to 10? This is a true statement. Yes, 0 is less than or equal to 10. So then I'm going to compute some velocity, print some velocity, increment time by 1. So time will now become the value of 1. I will come back and I will repeat the loop. I will test it with this condition. Is 1 less than 10? Yes. Do the loop again. So all these other things, doing the computation, doing the prints, that all happens, and I only had to write it in my code one time. I don't have to write it 10 times going through the loop. So finally I get through this loop right here, and I increment by 1, and now time is 11. I come through the loop. 11 is not less than or equal to 10. That's a false statement. So then I go and do something else in the program. I end the loop, I get out of the loop. So it is also easy for you to write an infinite loop, and your computer will sit there and try to run that infinite loop forevermore. So we don't want that to happen. You will have to take care in writing your loops. So part of the loop has to have a conditional, some kind of a condition that gets tested. So here is, for example, these are all of the different kind of operators you could have in your condition statement. Seeing if something is less than something else, seeing if it's greater, this is less than or equal to, this is, you don't just say with one equal sign because that would become an assignment statement. You have to do this like equal equal, which means is identically equal to. And this is a not equal, exclamation point, equal sign. That means not equal. So I have a little bit of a piece of test code to show you an example of doing this. Bring it up here. Here's my little example that I wrote. So I define two numbers, a and b. A is 5.5, b is negative 3.2, and I'm going to test. I say if a is less than b, then I'm going to print yes. What happens is you go through this code. So if the if statement evaluates to true, you're going to do what's down in here. But if this is not true, I'm going to skip this part of the code and go to the end, to just skip out of it because it's false, so I'm not going to evaluate it, and go to the end here. I'm actually going to talk about that in the next section of this book, but I wanted to show how you use one of the rational operators. Just an example. I will go ahead and run this code just so you see what it does. Compile my example, run it. So I just output the no, because why? I said if a is less than b, output yes. Otherwise, I'm just going to output no. So a is not less than b, so I just output a no. Why did I put all these extra new line escape characters in there? I just did that so things would look nicer for you to see. I'm going to change this a little, maybe you could see it better. Make my font a little bigger. Now you can see it. You can even go bigger yet, just to make it nice. Okay, so now it's maybe a little bit better for you to see. Let me fit that in my window here. Okay, good. Back to the PowerPoint. That was my little example code. So these are rational operators that you're using in your condition statement. So for example, the one I just did. You can also have logical operators as shown on this chart. So you can have something like is a less than b and b less than c. So let's do a couple of examples of that. So I just pasted my example in, but let me just say, put one other thing up here just to make it clear. This right here, this double ampersand, this is the logical AND operation. This one, these two slash marks, which is probably the shift on my keyboard, it's above the backslash key. In case you're trying to find that slash, vertical slash, it is above my backslash key. So shift backslash and it will give it. This is an OR function, an OR operator. This is a NOT operator, so not A, not B. So let's look at using these logical operators right now. So it's basically, here's my example. I'm going to use an if statement, but look at the if statement right down here. It says if A is less than B or A is less than C. So how do you evaluate that? The way I would do it, A is less than B. Is that true or false? A is 5.5, B is minus 3.0. That's a false. That is not a true statement. A less than B is not true. Go over here. Is A less than C? Check. A less than C. A is 5.5. C is 10. This is a true statement. And now I go look over here at this definition of an OR statement. OR is this is a truth table, is what this is actually called, as a truth table. So I have false or true. False or true. I go and look at this. False or true means true. So this overall condition statement right here evaluates to a true. And if it evaluates to a true, I'm going to do what's underneath this if statement and print out the word true. But if it evaluates to false, I will print out the word false. So if you think about it, it's sort of like our human language, an OR statement. Either I'm going to go to the store, or I'm going to go to the beach. If any one of those statements is true, then the overall statement is true. I have done something that I have done it. It is true. And is different. And the only way you get a true outcome is if both the statements are true. Okay, let's run this for a second. I will show it run. I already put it into my code, but I haven't compiled it yet. So let's do it. Recompile. Rerun it. Oh, what happened? I outputted true and false. What happened? Let's take a look at that. So back at the code, you can say if the OR statement evaluates to be true, point to it right here. I mean, A less than B or A less than C. If this evaluates to be true, I'm going to do what's down here in the brackets. Otherwise, I will skip down here and do what's down here. But what happens, because we're doing sequential programming, is this condition statement evaluated to be true, so I did what's down here in the body of the if statement. But then the program just continues on. It just continues on, and it did this next thing. So I'm going to say something. I print no matter what. And I will go over here and make this evaluate to false. So let's look at that statement. A less than B. Is that true or false? That's false. Or A less than C. That's also a false statement. Going back and looking at my OR statement, a false and a false will evaluate to a false. So save that and compile it again. So it evaluated to false this time, so I didn't print out what was underneath the if statement, which was the word true, and I just went to the next part of the program and printed out the statement I print no matter what, which is what we expected the program to do. So this part of the program got skipped. So let's do an example with an AND statement before we finish this up. If A is greater than B and A is, let's fancy it up a little bit, not equal to B, fine, B, print, what are we going to print? Oh, I know it, we'll print A greater than B and A not equal to B is true. And then no matter what, I'm going to print this statement because that's the way that's the problem with just an if statement without more down here, which we will learn about in a moment. Save that. Let's run it. Make sure I didn't make a mistake. See how it turns out. Compile. Run it. So A greater than B and A is not equal to B is a true statement, and once again I get that I print no matter what to come out. So when you're using these arithmetic, rational, and logical operators, they have a precedence associated with them. So multiplication is done before division, or multiplication is done before addition, and also in our logic statements, and statements are done before statements, before or statements. And is done from left to right, and or is done from left to right. So this is a repeat from the chart in the last chapter, but let's give an example. So this is actually a very ugly example, so I have quite a conditional statement there to figure out what's going to happen. So let's see if we can figure out what's happening with this conditional statement. So like I said, the way I usually approach it is I look at each, there's my and statement, there's my or statement, there's another and statement, and there's another or statement. So let's do test. A greater than B, that's a false. A not equal to B, that's a true. There's an or statement. C greater than D, that's a false. C equals 11, that's a false. C greater than D, that's also a false. So I could, well, first of all, I would never write a conditional statement this way. I would put parentheses in it and make it clear what's happening, and maybe even put some spaces in it so that it's much more readable. But let's tackle this bad problem the way it is right now. So a false, if I look at it this way, a false and a false and a true, and false and true evaluates to a false. Now what do I do next? Do I just OR it with a false statement? A false ORed with a false, that would equal a false. I could continue on, and then so I have a false, and I'm going to AND it with a false. That makes it become another false, and I'm going to OR it with another false, and that becomes a false. But that is actually not what occurs in this problem. So what actually occurs, how it actually gets interpreted, let me get rid of these, with precedence, using precedence. A not equal to B, that was a true. So, whoops. A not equal to B, that's a true. What actually happens, how the program interprets it, is it finds the AND statements first. So here's an AND statement. This one and this one. There's an AND statement. There's an OR. This is an AND statement. This one and this one. I'm going to group it together here. And then this is another statement. So what it actually is going to do is it's going to interpret these AND statements first. So, and then from left to right it's going to interpret the ANDs. False and true is a false. False and false is a false. Turns out we get the same answer either way. But warning, it could not necessarily be that way. So false or false would be a false ORed with another false. And the ultimate result will be a false. Now I could mess with this program and put parentheses in it and force it to interpret the results, the conditional statement, a different way, which since this is a very ugly statement to work with, I would definitely put my parentheses in if I wanted to force it a different way. So here's my example. First of all, this is very ugly, like I said, so I will put parentheses in to make it very clear. This and this, this and this. It's a little annoying sometimes. Go ahead and put space in if you want. Put space here to make it more readable. So that's a clearer statement for me. I'm going to evaluate is A greater than B, and I'm going to evaluate is A not equal to B. I'm going to put some more spaces in it and make it readable. C and D. Put spaces in, make it nice, make it readable. So let's say I wanted it to be interpreted. I could put the parentheses in however I want, but I'm going to change it slightly just to make the result different. So I'm going to make sure that I interpret this OR statement. Before, and I'm going to OR the result there. Okay, so I'm going to evaluate this and I'm going to OR it with these ORed together and these ORed together ANDed with this statement. So at least I stand a chance of interpreting what that phrase is. Let's see what the result is. Oh, I made a mistake. Yes, so I got some compiler errors. So I go back and I figure out where did I put the compiler errors. There's parentheses there. Right, this one is okay, this one is okay, and I'm missing one right here. Yes. Save. So now my statement is true. Now before when we looked at it, the statement was false, but now I've put parentheses in and been very clear, and I can have my conditional statement be true. So this one was a true statement. Okay, so now let's look a little bit closer at the way an if statement works. Okay, here's the flow chart for our if statement. So the if statement is represented by this selection diamond. If the statement is true, you evaluate something. If the statement is false, you go around the body of the if statement and execute what happens. You can have many statements inside here, but if the condition is not true that you just tested, you will skip all those statements and go to the end. In the code we just did, here I simplified it a little bit so it looks a little bit better. So you have always, pointing it out, you have always an if statement. If is right here. This is the condition that you are going to test that evaluates true or false, and then if it's true, you always evaluate what's between these curly brackets. So this is the body of the if statement. So you have a style choice here. There's some little points about style that I want to make. Some people start this curly bracket right here and then put the statements aligned and indented underneath the if. And some people start the opening curly bracket here and the closing curly bracket here, and then indent the statements that are inside the body of this if statement. So you always want everything to be indented. It makes it easier to read that what part is being evaluated if this is true. So if statement always has a condition in parentheses. There is no semicolon at the end. This is a mess up for a lot of people. So if statement has no semicolon in it, and then what happens if the if statement evaluates to true goes in this body of the body right here between the curly brackets. One of the things we didn't like about this program is that if this evaluated to true, then I printed the statement that the condition expression is true. I can't spell expression. Otherwise, then if it was false, I didn't execute what was in the curly brackets, and the program continued down here, and I have this other thing that would happen. So it would be really nice that I could test a condition and say, if it's true, do one thing, else if it's not true, do something else. And there is a way to do that. That is with our if-else statement. This is the flow chart for an if-else statement. So you come in here, you test if some condition. If it's true, you do what's underneath the if statement. If it's not true, you do what's in the else statement. And let me show you an example. Here's my little piece of code. I have set an integer this time, an integer I equal to 2, and then I say if I is less than 10, is that a true statement or false? That's true right now, so I am going to do what's in the curly brackets, which is print I is less than 10, and then I'm going to increment I, but I didn't do anything with it, but I want to refresh your memory that I is now 3 if I wanted to test that. Let's put that in there. That would be fun to do. So control copy, control paste. It is now, let's say, I is now %I, whatever the value is. So if my number happened to be an 11, I would instead, this would evaluate to be a false. So I go down to here to the else statement, and I would print something that number, do some other statement, whatever is required of me. And then after the true part or the false part executes, then the program execution will continue as before. So let's demo that one since I did an on-the-fly change. Compile it, execute. So 2 is less than 10, I is now 3, it did increment, and then that after the else statement I have a print command, I print no matter what. So that's what it did. Okay, let's look at an example again, and I'm going to point out something else new here. You can also nest the if-else statements. When you nest the if-else statements, I have the outside if-else, and please note that the brackets here are all aligned. And then, but inside this if statement, I have another if-else statement, and their brackets are all aligned. So you cannot have if, and then this else statement and the other else statement. It doesn't work. So I've changed this program. I is now equal to 5, and I say if I is less than 10. That'll evaluate to true. So I'm going to print a statement, and then this means I'm going to increment I, and I will get the new value. Then if I do another test inside, now I test I, is it less than 5? And then I will print value of I, or if it's not less than 5, I'll print this other statement. So after you get done with, if you entered this part of the if loop and you continued it, you would choose something here or here, and then you would come back out and do this other else statement. If this evaluated to false, you would do this other else statement. Otherwise, you come down here to the end of the program. So if you're going to either evaluate that part or you're going to evaluate that part. If you evaluate this part, you have another choice, another test that occurs in here, but when you're done here, you will come back out and execute the bottom part of the program after the if statements. So I'm going to run it and try it. Sometimes the best way is just to show. Remember, I is now 5. So 5 is less than 10, but then I incremented I and gave it, I has the new value, incremented and it became a 6. So I is now 6 and it's not less than 5. And then at the end of the program there's this print statement, I print no matter what. Looking back again at the code, let's look at it one more time. You get a different result. Pay attention to whether you do a pre-compound addition or a post-compound addition. So in this case, if I say plus plus I, I'm going to increment the value of I to 6, and then I is going to have the value of 6. But watch what happens if I do it the other way around. Save the program, compile again. Oops, I guess I didn't quite do that quite right. Alright, so C# will give you a different result than C does. I learned something new today. So I did become 6 and it's not less than 5. Same result. I need to double check that. That doesn't quite rub right with me, so I will double check that. The program we just did with the nested if-else statements can get really confusing and really ugly. So if you're really trying to sort of a bin that a number needs to go into, we have a switch statement for that. The switch statement is really to replace ugly, unwieldy if-else statements. So this is an example of a switch statement right here. So the keyword is switch, and then you have these different cases, which are different tests that you will subject your condition to. So if you look at the structure here, it's switch, and then it's in parentheses. There's no punctuation after that. Then you have the different cases that it has to do a test and match. Now it may be that the test that we do does not match any of these cases, in which case you need to tell the program what to do. So you make a default condition to it's something else to do in case none of our conditions match the case. So let's look at this program for a minute. I created an integer called code. So code is just some number, and I told the user enter code 10, 11, 12, or 13, and then I'm going to get the number that they enter and store it in this identifier called code. And so now my switch statement is going to test what the value of code is. It's going to, if code happens to be 10, I'm going to print a statement way too hot. That was a code 10. This problem I'm doing is not exactly like the one in the book. I messed around with it and wrote it myself. But I am looking at page 96 where they're using some kind of a temperature test. So if they enter 11, it's a little less hot. 12, it's still a little too hot. Case 13 was normal temperature. And then if the user enters some other number that's not one of the choices, I have a default case, a default place where the code will execute, and it says something not real pleasant. And then after the switch is done, and one of these cases, either a case that is a match or the default case, one of these gets executed, then you enter the switch, exit the switch structure, and continue on with your program execution. In this case, I have a print statement that just says test over. So a few other things to note. I have this being an integer. It's an integer called code that can assume the value 10, 11, 12, 13, or something else that some user entered. Switch does not have to be an integer. It can be a double, but it would have to match precisely. It can be a character. So I'm going to run this code. So enter code 10, 11, 12, or 13. I'll enter a 13. It says normal, code 13, test over, because test over was outside of the switch structure. Let's run it again. This time I'm going to be a not very good user, and I'm going to enter 16. And I get a message, you are an idiot, follow instructions, test over. So switch structure is a very nice, convenient structure if you have a bunch of conditions you want to test to and have the result fit into a certain category. It is much nicer than using nested if-else statements. So I'm going to go on now to example on page 98. This book is kind of neat because it has a theme running through it, and it's a theme of forensics. So this particular problem has to do with facial recognition programs. In facial recognition programs, what happens is usually that you have to compute ratios of different distances on the person's face, and then you compare it to other faces, and you can determine if these two people are the same, for example, or facial recognition can just look at the calculation of the different distances on the person's face and then say, yes, this person is a match, or no, this person is not a match. So in this problem, we're going to look at a couple of the features of this person's face, actually three people's faces. So in one of the ratios that we're going to look at is the ratio that we're going to look at this outer distance between their eyes. So this is some distance in centimeters. Maybe the first example, image 1, is 5.7 centimeters. And then the other distance that we're going to look at on the person's face is the distance between the nose and the chin. So this distance right here. And so if you this distance, for example, in image 1 was 5.3 centimeters. And so I can go through three different images, and I can have these distances from their images, and then I compare the images, and wherever these distances are the best match, you can match the images. So let me give an example. It's not actually the distance that they compare, but they actually compare the ratios. So if I have this first image, image 1, and I compute a ratio of the distances that I care about, which is the ratio of the eye distance to the nose-chin distance. And I compute that ratio. I end up for this person, for image 1, so I'll call it ratio 1. I end up for this person a ratio of 5.7 to 5.3, and that equals 1.08. It's just a ratio, it's just a number. Now if I take a second image, which I don't have a second image up here, but I could have put any image of another person, and I compute this same ratio, I might find that this person, which is the data on page 99, has a ratio of 6 divided by 5, which is 1.2. And then I take the third person's image, or the third image, maybe you're trying to match images, and I calculate their ratio, and their eye distance is 6.0, and their nose to chin distance is 5.6, and it gives me a ratio of 1.07. Now these ratios, I got to compare these ratios and see, is the distance between 1 and 3 the smallest, the distance between 1 and 2 the smallest, or the distance between 2 and 3 the smallest. And whoever has the smallest distance, or which is the difference in their ratios, those two images would be the closest match for example, I can see that the difference between, I'm going to use the kind of the identifiers that the program uses. The difference between 1 and 3 is 1.08 minus 1.07, which is only a difference of 0.1. But the difference between 2 and 3 is this minus this, which is going to be 0.13. And the difference between 1 and 3, 2 and 3, 1 and 2, 1 and 2, which would be here to here, that is 0. Do the math. 1, 2. Right. So the difference between 1 and 3 is the smallest, so image 1 and 3 are the most similar to each other. And that's basically how the facial recognition program works. However, one little correction probably needs to be added to this program, is that I may have done some subtraction, some difference calculation here that made this be a negative number. So we are, if one of those is a negative number, what we really want to do is find the absolute value of the difference between the ratios, and that in our math function is function ABS, for function absolute value, and you put some difference in here, like maybe I did 1.07 minus 1.08. So this math function, built-in math function under the preprocessor directive math, will find the absolute value of a number. So that's basically what the program has to do. Real facial recognition programs comparing images would use a lot more than 2 different ratios. They would use a lot of different ratios to do this calculation, to do the image comparison, I should say. So let me get rid of some of this for a moment. So in our how you go about writing a program process, the process is very important, so I don't want us to forget about these processes of how to write a program. So remember, you have to have the problem statement. So my problem statement is really compare images and find 2 images that are the most like each other using 2 different features from the person's face. So that really has to do with what our problem statement is. We have to clearly understand what the statement is. Next, we have to clearly understand what the inputs and the outputs are. So the inputs are image 1 eye distance, image 1 nose-chin distance. That's an input, that's an input. And the same thing happens for image 2. So there's an input, there's an input. And the same thing has to happen for image 3. So there are 6 inputs that are needed for this program, which are dimensions from 3 different images. So then there's the program. And the output to the program, what should the output of the program give? Out should give 2 image numbers. Which 2 are alike? Which 2 image numbers are the most alike? Is it 1 and 3? Is it 2 and 3? Is it 1 and 2? So I want 2 images, 2 image numbers to be output. The 2 that are most alike. The next step in programming, if we follow this good practices to developing programs, would be to develop our algorithm. So we can do, let's give a chance of doing a flowchart, because we haven't really done a flowchart yet. So the program would need to have a start the main, enter the main. That's supposed to be an oval. It's going to get the student input, or get the feature input somehow. Then it's going to do a bunch of calculations of ratios, calculate ratios. Then it's going to, what else is it going to do? It's going to calculate differences, which a delta symbol means differences. Calculate differences in ratios. And then it's going to have to make some choices here. Maybe have to think, is this a true false? It may be a true an if statement going on. If the two images that are alike are 1 and 2. This is kind of a pseudo statement. Then I'm running out of room. Print that answer. Otherwise, go on to the next part of the program, which should be another if statement. If 1 and 3 are alike, print something. And then one more time, I will have another if statement. If 1 and 4 are alike, maybe I should write all of that out. So let's go ahead and write all that out so you see it. Shrink this up for a minute. Okay, so I'm actually going to continue this program on down over here. So let's just bring it around down here because I ran out of room. So if 1 and 2 are alike, I'm going to print some statement about 1 and 2 being alike. Otherwise, the program is going to come back over here, and then I'm going to see is it 1 and 3 that are alike? If the answer is yes, then I'm going to print a statement that it's 1 and 3 are alike. If the answer is no, I'm going to continue my program execution. I'm going to have one more if statement, or one more test. Is it 1 and 2 that are alike? If yes, I'm going to print some kind of a statement that says that they're alike. If no, I'm going to continue the program execution, and then I'm going to exit the program. So there's my rather sloppy, because I can't write with the electronic pen very well. Looking at the monitor in front of me and trying to write is, whoops, not the same as writing on something that's right in front of you. My program just crashed, I think. Yes, lovely PowerPoint crashed on that last moment, so now I have recovered it, minus my lovely flowchart that was so messy. So I'm now going to give an example of the program that we just talked about. So things have shifted a little. There it is. There's the program all written. So I've declared some variables. They're all double values. So eyes1, eyes2, eyes3 are the distances between image 1's eyes, image 2's eyes, and image 3's eyes. So that is this distance AD in A to D in 3 different images. Nose, chin, 1, 2, and 3 for 3 images. I have to compute 3 ratios, 1, 2, 3, and then I have to find difference between 1 and 2, difference of the ratios between 1 and 2, 2 and 3, and 1 and 3. So here's get the values from the images. So I'm going to ask the user to enter these distances from the images. I'm going to compute the ratio of the eye's distance to the nose-chin distance for the 3 images. I'm going to compute the difference between these ratios between image 1 and 2, 1 and 3, and 2 and 3. And notice I have used this function absolute value to make sure I don't have a negative sign. Then I have the 3 if statements that I did in the flowchart, my pseudocode flowchart. So if the difference between image 1 and 2 is less than the difference between 1 and 3, and the difference between 1 and 2 is less than the difference between 2 and 3, if both of those are true, the best match is between images 1 and 2. Think about it, write the numbers down, test it, make sure that you like this if statement. If this conditional statement does not evaluate to true, I'm going to go to my next part of code, which is again an if statement. And if this one does not evaluate to true, I'm not going to print that statement then, and I will go to my third if statement. This code could be improved a little bit. I could have an else statement in the end, because what happens if 2 images were exactly the same? We could have a little error in this program. But anyway, let's run the program and see how it works. I'm going to compile it. Oops. I called it exercise 3.1 because that's what it is. Run it. So enter the eye distance and nose chin distance for image 1. So I have to enter 2 values, enter eye distance and nose chin distance. So I'm looking at your textbook at page 99, and I see there's a 5.7 for image 1 eye distance, and nose chin is 5.3. Enter eye distance and nose chin distance for image 2. 6.0, 5.0, and do the same thing for the third image, 6.0, 5.6. Oh, I messed up. Probably didn't know what to do. I didn't have any kind of error correction in there. I'm going to run the program again. So we will talk about error correction at some point in this class, because clearly the user messed up and entered bad values and the program didn't catch it. The program should have caught it. Best matches between image 1 and 3, and sure enough, when we did our calculations, the best match was between image 1 and 3. So program worked nicely. I think it's kind of neat to see how image matching or facial recognition programs would work. It's all about the dimensions between the features that are recognizable in the image.